In muscle contraction, the muscle fiber membrane can conduct action. Potentials down the membrane. The response to one action potential in one motor neuron corresponds to a contraction in the fibers of the whole motor unit. The whole process goes as follows. An action potential is triggered and travels to the terminals where calcium enters through channels. Calcium will trigger the release of acetylcholine into the synapse. It diffuses to the motor end plate across the neuromuscular junction. It binds to nicotinic receptors on the end plate, increasing the permeability of sodium and potassium. More sodium will move through the membrane and potassium will move out. It will depolarize the membrane and produce an end plate potential across the fiber. Down through the T-tubules, it induces the HP receptors to open ryanodine channels, allowing the release of intracellular calcium from the sarcoplasmic reticulum. Calcium will bind the troponin on the actin filaments, causing tropomyosin to move and expose the actin binding sites. This allows myosin cross-bridge formation on the actin. ATP will bind to myosin, breaking the cross-bridge formation. The ATP is then split, energized. The myosin cross-bridges for more. The cycles of cross-bridges formation will produce the sliding filament model. Meanwhile, cytosolic calcium will decrease as calcium ATPase activity actively transports calcium back into the sarcoplasmic reticulum. Loss of calcium from troponin restores the block on actin sites. The cross-bridge formation will then cease and cause the muscle to relax.